Hey everyone, and welcome to this explainer. Look, if you are running a print production floor, you already know that time is your most valuable asset, right? And consistency, well, that's your ultimate currency. So today, we're delivering a high-signal, zero-fluff breakdown of DTF powder application mechanics. Our goal here is actually pretty simple. We want to help you understand the precise physical mechanics you need to really protect your margins and consistently scale your operations. Smarter printing starts right here, so let's get into it.
All right, so think about it this way. The adhesive powder is the literal bridge between the ink and the substrate. This really reframes how a lot of operators think about the powder phase. Just covering the wet ink, that is absolutely not enough. Perfectly uniform coverage is the absolute non-negotiable goal here if you want to ensure a proper bond. Because if that bridge is structurally compromised in any way, the entire garment is compromised.
So here's our roadmap for today. First, we'll cover the mechanics of powdering. Second, over versus under powdering. Third, humidity control and clumping. And finally, standardizing for consistent execution. We're going to look systematically from the machine mechanics all the way to your environmental guardrails. Okay, let's jump right into section 1, the mechanics of powdering, and specifically understanding that automated shaker unit.
Now, while manual powdering works perfectly fine for low-volume prototypes or, one-off samples, true scaling absolutely demands automated hardware. You literally have to remove the human variable from the equation entirely. You simply cannot build a predictable, high-volume operation by handshaking film. So inside that automated unit, the process happens in 4 distinct mechanical steps. Step 1, the wet film enters a tray filled with hot melt polyurethane powder. Step 2 is really where the magic happens. The beater bar rapidly taps the film. Step 3, this tapping knocks all that excess powder right off the unprint areas. And finally, step 4, the powder that's actually embedded in the wet white ink settles perfectly and evenly. I want you to really focus in on that beater bar. It is the critical component of the entire vibration mechanism. It's doing 2 crucial jobs at the exact same time, knocking away the waste and settling the required powder into a perfectly uniform layer.
Moving right along to section 2, over versus under powdering, and the real dangers of incorrect vibration. Listen, precision is absolutely everything when you're dialing in your shaker unit's vibration frequency. If you just sort of set it and forget it without calibrating for your specific film and ink load, you are actively setting yourself up for failure. Let's look at the 2 extremes here. First, weak vibration. If the tapping from the beater bar is just too weak, excess powder remains on the film. And when that overpowdered film is cured, it creates this thick, super stiff hand feel on the final garment and leaves a highly visible, totally unacceptable glue residue around the edges of your design. Not good. But then, on the flip side, we have aggressive vibration. If that beater bar is hitting way too hard, it literally strips the powder right out of the wet ink. The result? Underpowdering. And this leads directly to weak adhesion and inevitable wash failures. In both of these scenarios, guys, you are losing money, losing margin, and seriously risking your shop's reputation. Which brings us to section 3, humidity control and clumping. This is all about locking down the invisible variable in your shop. You can have your shaker unit perfectly dialed in, but if you ignore the environmental conditions on your production floor, your process is going to silently derail. Hot melt polyurethane powder is highly hygroscopic. Basically, this means it actively drinks up moisture directly from the air around it. Anyone who has tried running a high-volume batch on a rainy day with the loading bay doors wide open knows exactly what happens next, right? The powder absorbs ambient moisture and just clumps together right there in the shaker tray. And clumped powder simply cannot distribute evenly across wet ink. Those clumps block the smooth flow of powder, and the immediate result is bald spots on your transfer. A bald spot means absolutely no adhesive, which means a failed transfer, and ultimately a ruined garment. So, what's the magic number? The crucial operational metric is 45 to 55%. Controlling your shop's humidity to this strict 45 to 55% range is exactly how you prevent that clumping from ever happening in the first place. Honestly, this is a non-negotiable metric for any serious DTF operation. By locking your environment into this specific window, you completely eliminate the hygroscopic nature of the powder as a production variable. Plus, there is a massive operational bonus here. It makes training new operators significantly easier. When the environment is actually stable, the machine behaves predictably, and troubleshooting is no longer a daily headache for your floor staff. And finally, section 4, standardizing for consistent execution. Let's take all this from micromechanics to your macro business. Because understanding the science is really only half the battle, right? Implementing it as a rigid operational standard is where the profit is actually made. By controlling your humidity and locking in your shaker unit's vibration metrics, you achieve 4 major things:
First off, you completely eliminate the variable of weak bonds. Second, you ensure incredibly simplified execution on the production floor. Third, you're going to see massively improved consistency across those long garment runs. And fourth, as a result of all of this coming together, you actively protect your overall product margins. Remember, in print production, you rarely lose your margin at the printer itself. You lose it in the finishing and the uncontrolled variables. Standardizing your powder application is quite literally about protecting your final product. Textile operations only ever scale when they become predictable.
Which leaves us with this final, somewhat provocative question to consider. Is your powdering process a rigidly standardized metric, or is it honestly just a daily guessing game? Because true scaling only happens when you aggressively reduce variability, and your process becomes totally 100% predictable. So take a hard look at your shaker unit's vibration settings and your shop's humidity gauge today. Thank you so much for joining me for this explainer. Apply these insights straight to your floor, protect those margins, and we'll see you in the next one.